This video, we're going to look at some basic logarithm rules and examples. A couple things to remember. If you have, say, the log to the base a of a to some function of x, then these are inverse functions, so that's going to end up giving you h of x like this. So, for example, if you have the log to the base 3 of 3 for x plus 2, for example. Again, since log base 3 and 3 are inverse functions, is going to be 4x plus 2. And of course, whenever you see ln, like ln, that's the same as log to the base e. So, for example, if you have log e, say, to the 6x, that's going to be the same as log to the base e. And again, since those are the same, this is going to be equal to 6x like that. Now, even if they don't have the same base, we have the rule, let's say log to the base a of any function here, say to the r, this is going to, you can always bring the r in front, log base a of x like this. So you can always bring this exponent in front. So for example, if you have something like this, let's say log to the base 8 of x plus 3 to the 4th, you can always bring that forward. Also, we have some general log rules. So let's say if you have the log of a product, say the log, doesn't matter what the base is, x times y, this is going to be equal to the log of x plus the log of y like this. And if you have a quotient, this is going to be log of x minus log of y like that. So if the argument is multiplied, you can break it up into a sum. If you have a quotient, you can break it up into a difference like that. Now let's look at some more examples. Let's say we're given a problem like this. We have log to the base 9 of 3x plus 7 plus log to the base 9 of x plus 6 plus log to the base 9 of x minus 4. And we're supposed to rewrite this as a single log. So a minute ago, we said that you could write a product as a sum. So in the same way, you can write the sum as a product. So we could actually put this all together, and we could say this is log base 9 of 3x plus 7, x plus 6, x minus 4, like this. And let's do another one. Again, let's write this as a single log. Log of x minus the log of x plus 10 minus the log of 7x plus 9. And we want to rewrite that as a single log. Now, as I said before, sums turn into products and differences turn into quotients. So like in this case, we have a positive log here. So that'll be in the numerator. And the negatives will be in the denominator. Now you could have done that those one at a time, but I just took a shortcut. Now let's combine some of the ideas that we looked at previously. So suppose you have something like this, 3ln. Now that's the log to the base e, x plus 2 cubed. X squared, like this. So again, we were going to write this as a single log. So again, we'll bring again, working backwards. Remember we said if there's an exponent here, we can bring it forward. Same thing here. If there's a number or variable in the front, we can bring it to the exponent. So let's do that first. And let's bring this up here. When we do that, this will give us 5 times 3, which is 15. And we'll bring this up here. And to the 20. And all I did was bring everything in front of the log up to the exponent. Wait, now we have to do that before we're allowed to write this as a product. We can't have anything in front here. In other words, we could not have written this as a product and a quotient right away. We needed to get rid of anything that was in front of the log. Now we can put everything together. These were added, so they go in the numerator, and then this was subtracted. That goes in the denominator. Now, on these ones, we're going to go the opposite way. We're going to start with, say, product and or quotients. And write these as sums or differences. And so let's write this as a sum and or difference. This can be written as log plus log, like this. Let's take a look at a couple more. So again, we want to write this as a sum or difference. This. Now, this time we have a number in front. Now this time we could, since it's the same number, we could write this as 3 log of x minus 9 plus 3 log x plus 3 to the 7th and so on. But I'm going to bring up the number first. So what I want to do is bring this up to the exponent. This, and I'm going through all the steps so everyone can see. So again, remember, if you have the product of things to an exponent, that exponent is going to be distributed to every factor. So the 3 will be here, 18. 21. Like this. Now that we got that taken care of, we can write this as a sum because we have the product of 3 things. I should put some equal signs here. So this can be written as log. Oh, by the way, when we have log with no base here, then that means the base 10. Log with nothing is base 10. Now, another way we could have done this, and let me just show you here, because this 3 is multiplied with this would be the same as having 3 times each. So let me do this again. So like, for example, let's start here, and we could have written this 3 log x minus 9 to the 6 plus 3 log x plus 3 to the 7th plus 3 log x squared plus 3x minus 1 like this. And then we could have brought the 3 back. So this would be 3 log x minus 9. And we bring this 3 up here, that comes 18 plus log three 21 plus log x squared like this. That would be another way of doing this. And as you can see, we got the same answer in both cases. And let's take a look at one more. Again, we want to write this as a sum or differences of logs. Once again, in the numerator, we have these two. So it can be written as ln x to the 4th minus 7 plus ln squared plus 6x plus 3 to the 4th. And then in the numerator, we have, excuse me, in the denominator, we have this. So again, the positive one to go with the ones in the numerator, the negative with what was in the denominator. And sometimes, again, depending on what you're doing, maybe you want the final answer to have nothing in the exponent. Sometimes it might, you might do a problem that'll say have exponents of all 1. If that was the case, we would go one step farther. Like this. And that would be our answer. Now we're going to look at a little bit different type of log problem. Say in this case, we want to solve for x in each of the following. So let's take these examples here. So suppose we have log of 2 x plus 1 log of 2 x minus 1 equals 3. And we want to solve for x. First thing we're going to have to do is write this as a product. This. Now, in order to get at this x, these x's, we're going to have to do something with this log. And you remember before we said that log, say, of 2 would give you just the exponent. Now, there's another rule that you can use. Let me show it to you here. That I'm going to put 2 under each of these. So I'm going to do the same thing to both sides. see what I did? I sort of raised 2 to the power here. And so I took on the left-hand side, I put 2 down here and same thing over here. So I did the same thing to both sides. And just like we were talking about before, if you have log of 2 to the 2, those are inverse functions. Same thing here, if we have 2 to the log base 2, these are inverse functions. So what you have left on the left-hand side will be x plus 1 times x minus 1 equals 2 cubed, like this. So again, because this is 2 and this is log of 2, those are inverse functions. We're left with just that exponent. Now, of course, on the right-hand side, that could be written as 8. I should have already done that, but let me do that now. So that let me FOIL this. Remember, if you FOIL it, you get x squared plus x minus x, those canceled, minus 1. So that's going to give us x squared minus 1 equals 8. And let me bring the 1 to the other side. X squared is equal to 9. And then remember, we take the square root of both sides. Remember, whenever you take the square root, it gives you a plus and a minus. So that means x is going to be 3 and now it looks like and x equal minus 3. The only problem with this is if you put this back, x equal minus 3 back into the original function, that's going to give you -3 plus 1. So that'll be log of a -2. And you can't take the log of a negative number. So even though we got 2 answers, when you put it back into the original just to check it, you can't have a negative number in there. So that means we can cross that one out. Only this one works. So let's look at some more. Let's take a look at this example. Once again, we're trying to solve for x. This solution. So again, we can take the quotient of this. This. Again, because this was the negative as x squared over x, one of the x's cancel, get that. So once again, we want to try to get at this x, so we're going to have to raise this up to both sides. Like this. So in other words, I put 6 under here and 6 under here. Once again, 6 and log 6 are inverse functions. So that means we're going to be left with just what the argument is there. Then the right-hand side, 3 squared is 36. So let's look at some more. Let's look at ln x minus ln x minus 4 equals ln 3. Once again, ln means the natural log or log base e. And again, these are differences. So that means that's going to be the quotient. And now this time, you could raise both sides to the e. In other words, remember these are log base e, and you could put e under each of these, or just recognize the fact we have a log over on the left-hand side and a log on right. As long as we only have one log on each side, if there were more logs here, we couldn't do this, but we just have one log on each side. They're both the same, both base e. So that means that if these are equal, then the arguments are equal. So you could actually write this as this. And once again, if we multiply this over, over here, this is going to give us minus 2x minus 12. When we divide by minus 2, we get 6. Let's keep going here. And let's take a look at this one. So again, we want to solve for x. To write the sum as a product. And once again, in order to get at these variables, we're going to have to make this 5 log 5. Again, we pick 5 because that was the log. And we have to do the same thing on the right-hand side. Put a 5 underneath there. And again, these are inverse functions. This, then again, when you multiply this out, FOIL it out, you end up with x squared. Then it's going to be minus 4x plus 4x. Those will cancel. So minus 16 is 25 like this. X squared is 41. And once again, take the square root of both sides. And that's not a nice square root, so if just write it like this. And now the only thing is when we check this, this is a little bit bigger than 6. So when we put this into here, notice we'll have the log of some negative number because that's only 4, say minus 6 something. That's going to be log of a negative, so that's not going to work. This one, it'll be positive here and it'll be positive here, so that'll work. So really only this one works in this case. And again, let's try one final example here. This, and once again, let's put these together. So put this as log 3 x plus 4 log 3 2 x plus 4 like this. Now again, since this is this log base 3 here, the log base 3 here, there's only one log on each side. Remember, if there was anything else over here, anything else over here, we couldn't do this. But if these two are the same, we can make the arguments equal. This, and let's put these together. And again, now we need two numbers that multiply to give us -8, but add to give us a +2. So that looks like it's going to be a +4 and a -2. Again, if you couldn't see that, you could use a quadratic formula. So the answers now are x equal -4 and x equal 2. Once again, we have to check these. Now, notice if you put -4 into here, that'll be the log of a negative, so you can't use that. Now let's check the 2. If you put 2 in here, log of 2 is good. Put it to the log of 6 is good. That's good. Log of 6, so that's okay. So our only answer is x equal 2. So there you have some basic problems for rules for logs.